Hello everyone and welcome to another processing tutorial, this time for Pickering's triangle, which is part of a supernova remnant in Cygnus. Now the data here was collected using an OSC camera from my city centre back garden, and this tutorial should be a little bit simpler than the last few ones I've done because we've just got two integrations here. The first one is 30 minutes of data that I gathered using an Optilong L quad enhance. We can hardly see the supernova remnant at all. It's not a problem. We only want this data for the stars. So RGB data so we can have reasonably accurate star colours. And the second integration we have here is 16.5 hours using an Optilong L ultimate filter. So that captures hydrogen alpha and oxygen 3. So what we're going to do is process this up to create a bicolour image with accurate star colours. So to start with, I'm going to create clones of these two source integrations just in case we mess anything up and have to go back. Then we're going to run integer resample because I'm oversampled, so I want to downsample my L quad by 2 and then my alt by 2. Right. Next thing is we want to make sure these two images line up exactly. So to do that, we're going to run star alignment. The reference image, let's choose the one that looks the best, shall we? Pickering integrated the alt on here. So the view, the view here is alt, and the target image is the view L quad. I'm going to click on the circle button there, and that should run that. Right, now to see this image, we're going to just run a quick unlinked screen transfer function. There we go, we can close the original, we don't need that. And then we're going to give it a slight crop. I'm going to hold down Control as I move this in, just a slight crop in. And we want to apply this exact crop to both images. So I'm going to drag this triangle over to the other image and then click the tick to apply it to the one that's selected, which is currently the L quad. Right, we're off to a good start. Next we're going to run image solver on both these images. This is going to give PixInsight lots of info to work with. So we go to script, astrometry and image solver. And if you're using an astro camera, it should have all of this info built in already because of the FITS data that it's embedded within. So we're just going to click OK for that. And that's done. You won't see any difference, it's just that PixInsight now has more information about the image. And let's do exactly the same thing for our ultimate data. Next I'm going to run blur exterminator, which is going to sharpen up these images and help to counter a little bit of the blurring effect of the atmosphere. Now to do that we need a bit of information about each image called the PSF, the point spread function. Blur exterminator can calculate this automatically, but I personally find I get better results by going to render PSF image, which may be a separate download, and I evaluate and I get that number manually. And what we want is to look for the two full width half maximum values, the x and the y. We calculate what's roughly between the two, so let's say 1.56. That is the number we need to keep in our head for when we load up blur exterminator. We're not using automatic PSF, we are putting in 1.56, which we just calculated, and I tend to keep everything else just the default. And then we're going to run that. And that sharpened it up a little bit. It is hard to tell, but if you zoom in, you can tell a little bit. And we're going to repeat that process for the alt data. So we're going to go to render, PSF image, and evaluate. And then the number between those two would be 1.34. That's what we're going to put in here, 1.34, and then run that on the L ultimate data. Okay, that was done pretty quickly. Next, let's sort out the colours in these images. To do that, we're going to use what we should do next is the gradient removal. How could I forget? Very important. Right, easiest way to do that, SETI Astro, which is a separate plugin, but it's free and it's brilliant, really recommend it. We're going to go to automatic DBE. We're just going to leave everything as the defaults on here, by all means you play about with it, see what works, but I find the defaults work quite well, and I'm going to click execute and give it just a moment. It doesn't take very long. And then we get the extracted background, which we can take a look at if we like. But the main one here is this new image, which should have a smoother background with gradients removed. Very important, especially if you're imaging from a city like I am, because you have all sorts of nasty gradients to deal with. Let's do exactly the same thing now for the ultimate data. So automatic DBE and execute that. Let's take a look, just out of curiosity, the background that's been taken out. But this is the good stuff. This is what we want. Let's delete that one. And now we can do the colors. So we're going to run SPCC on our L quad. Now SPCC works best if you can specify a region of interest that is a blank bit of background. And the easiest way to do that is another SETI Astro script called find background. I'm going to leave everything as defaults again, just click search, give it a moment, and then it should pop up with the background. You can zoom in just to have a look if you're curious. That's what this program says is a background. So with that selected, we're going to go to SPCC. This is broadband data at the moment we're working on, this L quad, so we don't need narrowband filters ticked. I'm going to leave that checked, and our region of interest is what we just calculated, that background. Let's run that, and it should help make our colors a bit more accurate. And we get this graph out at the end. Don't need that. This is all looking good. We don't need that background anymore, so I'm going to right click on it and delete. Then let's run that same process, almost exactly the same anyway, for the ultimate data. So to start with, we're going to find the background and then load up SPCC, which I say in all my videos and I'll say it again, SPCC is not really designed currently for use with dual band filters, but I find it works fine, so I have no qualms using it. I'm going to click narrowband filters mode. My Optilong L Ultimate has band passes of about 3 nanometers, so 333, it's fine. And then our region of interest is what we just calculated. Now let's run that and see what it does to the colors. Okie dokie, this gives us a good solid starting point for these two. Now we've done quite a lot, haven't we? So perhaps we should make some clones of these in case we mess up and need to come back. For the next step, we need to play about with our stars, don't we? What we need to do is remove the stars from this image so that we can then put just the stars back in at the very end. And remember, these are the stars we want because these are the broadband stars, which have better colours than the narrowband stars. So in order to do that, we're going to stretch our data. And the easiest way, statistical stretch in SETI Astro. Let's refresh our preview. We can hardly see any nebulosity, but that's alright, we're not interested in the nebulosity, we're interested in the stars. Let's boost the curves a little bit. We don't want our stars to be too bright or anything because then they overpower the nebulosity later. And if we can get this looking like the stars at least looking how we want at this stage, it means we don't really have to do much with them later on. So I'm just going to click execute on that. And then what we need to do is remove the stars. And the best method, it might seem a bit convoluted, but I'll run through it all. This is the best method that I found anyway. So we make a clone of our star image and we load up StarNet 2. I use StarNet 2, other people use the, what's it called? The StarX or whatever, like the blur exterminator equivalent. We've stretched our data so it's not linear. We're just going to remove the stars from this particular image. Okay, and at point of interest, even just 30 minutes of data, and you can actually see some structure in the supernova remnant there, which I think is quite neat. Remember, we're from a city centre. Right, so we've got our stars image, our starless image, and what we're going to do is find a utility called Screen Stars. This is another free download, but it's really good. So we're going to go to Mode, Star Removal. The star review is this one here, L quad registered ABDE. And the starless view is the one that we just made over here. That is L quad registered ADBE clone 1. And we can see here preview, just stars, no nebulosity. Perfect. We're going to click tick on that. And hey presto, we have our star field. We don't need those two images, so let's get rid of those. And I personally like to boost the saturation of these stars a little bit. So to do that, I'm going to go to color saturation. I'm going to click on the circle just so I get a real-time preview. And there's a little yellow dot here just at the right. And if I click and hold on that, I'm going to move that all the way up to the top. And that's going to give the star colors a good boost. You don't have to do that, certainly not, but I think it works quite well. So we're going to minimize our stars. Let's put them out of the way there, and we'll come back to those at the end. Now let's return to the main event here. Next step for this, we don't need the stars in this, do we? Because we're going to be using the stars that we've taken out of the other image. So I'm going to load up StarNet 2. This is linear data, we haven't stretched it, and I'm just going to go ahead, activate that so it'll run through and take out all of the stars. We should be left with a starless image. A bit like that. I'm just going to make a clone of that. Next step is where some of the magic happens. We're going to go to another SETI Astro script. This is perhaps my favourite one of all. Where is it? Perfect Palette Picker. And this, in the olden days before this, it was quite a headache to merge the data from different filters. But here, does it all automatically. So we've got OSC H2O3 dual band data. That's what we've got. That's Alt-A DBE. You can always check just by looking at the name at the top of the window. And it is currently linear, we haven't stretched it. Let's click Create Palettes. Just like that, it gives us lots of options. And you can click on any one you like, or you can click on multiple ones and it will create multiple files. I think that 4-ax is quite good for this, so I'm going to click on 4-ax. And then when I close this, ta-da, we have a 4-ax palette image. And it has also been stretched for us, which is quite handy. Let's make a clone of that. Now we can go ahead and process up this image. I think the first thing it needs is some curves transformation, because we want the background to be a bit darker, and the actual nebulosity, we want that to stand out a bit more, don't we? And if we click on the little circle at the top left, we can see a before and after preview to make sure we're always heading in the right direction. If we like that, then we click on the blue square. And then it suddenly looks terrible here, but that's just because it's the real-time preview window that's still open. And if we applied the changes again, it would look like this. But we're not going to. So we just close that, and this is what we got. This image is looking pretty noisy, isn't it? So I think I'm going to run some noise exterminator at this stage. Noise exterminator is really good. There is a lot of noise, so I'm going to be quite heavy-handed with it. Let's do 0.9, more than I normally do, but let's see if it works. Oh, it's a bit mushy, isn't it? If I click undo, redo, I think that's a little bit mushy. So what I'm going to do is just take it down. I think I flew too close to the sun then, didn't I? Let's try 0.75 instead of 0.9. Alright, I think that's a bit better. Lots of things we could do next, but I think that we want to work on the nebulosity a bit rather than the background, or at least we need to treat them as separate entities at this stage. So to do that, I am going to go to range selection and create a preview here, and we're going to create a mask that we can work on. So I'm going to move the upper limits, going to make it smooth, we just want it to be kind of black, appear black where the nebulosity is, and that's not too bad actually. I'm going to click on the square to create that. And then to apply this mask, I'm going to click and drag on the name and move it over to underneath the name of the image we want to apply it to. Let go, and then you'll see it turns brown there, and we can see it looks horrendous. That's just a preview of where the mask is. If we click on the little magnifying glass up here, that turns that preview off. And now if we open up our curves transformation, when we apply our curves, it's only doing it to the background. So what we can do is darken the background a little bit more without darkening the main structure there. Okay, pretty good. I'm going to say OK for that. And now what we can do is invert that mask so that we can just work on the nebulosity and not the background. So to do that, we just need this little button here, invert mask. Click on that, and let's go back into curves, shall we? And then just give that a little boost. Again, check before and after, before, after, heading in the right direction. Now I like to have sharp images, so I'm going to go to unsharp mask and click a real-time preview, and the default is way too high, so it looks really bad. Let's do a close-up view though. Play about with the amount. We take it right down like that. It doesn't really do much. What we want to do is just kind of move it up until it starts to look a bit too crunchy. Before, after. That's probably a kind of a limit there. Let's apply that. And because we've done this with the mask up, it's not going to sharpen the background. We don't want to sharpen all the black, because then that'll look like extra noise. But this isn't too bad, actually. We're getting there, aren't we? Let's, what should we do next? Let's remove that mask. We'll keep it in case we need it later on. I'm going to create a clone of that. And let's play about with our colours a little bit. So to do that, we're going to go to a very neat little function in Toolbox called Selective Colour Correction. This is another one that I really like. This allows us to change our colours quite easily, play about with things and just see what it looks like, which is brilliant if you're a visual person. We're not doing any complex maths here to the numbers, we're just playing about the sliders and seeing what results we get. So the mask is red, which means that anything here is going to affect the red colours, and you just can play about with them however you like, and it will update and you can see there what it actually looks like. So I'm just moving things at random here just so you can see, but you can do it more methodically. When you want to reset something, so I don't want to change that, you just click on the little icon to the right, little X and the arrow, and it moves it back. So let me have a little play and then we'll see what I get out of this. Alright, this is what I played about with and got for the red colour. So I put the cyan down a bit and the magenta down just a touch, a little bit more on the yellow, boosted the red quite a bit, and then 20 on the luminance, 40 on the saturation, 40 on the contrast. So if we do the before and after, it just gives more pop to that red colour. And once you're happy with what you've done for that one particular mask, then you have to click apply. It's very important because if you go and choose a different mask, it will forget everything you've just done here. I make that mistake too often. So we're going to click apply, and then I will embed that in the image. And then let's alter another colour. This time cyan, and I'm going to go through the same process, play about with the sliders and see what we come up with. And this is what I settled with. Now the reason I cut out all of me playing about the sliders is that I can easily spend 10, 20, 30 minutes or longer playing about with these. It's a bit boring to see me adjust each one. So I just skipped to what I've settled with. So the cyan mask, I boosted the cyan quite a lot and the magenta quite a lot, a little bit more on the yellow, nudged the red down a bit, increased the blue a bit, and then boosted the luminance, saturation and contrast. And then we have before and after, before and after. And I quite like that, but it's all down to personal taste, so whatever you like you go with. Let's click apply. And then once we close this, we have our image that has been adjusted. As ever, lots more that we could do with at this stage. We could play about with curves more, we could do some more sharpening, some more noise reduction if it needs it. but I think that for now we should just put the stars back in, see what that's like. So we're going to go and find, what's it called, screen stars, there we go. And we're not doing star removal anymore, we are doing star replacement. So our starless view is called final thorax, and our stars view is just called stars, because that's the one that was made before stars is the default name. Let's click tick on that. And hey presto, looking quite good, I think. Now at this point we might like to use integer resample to get that resolution back. So starry, let's upsample by 2. And we may also like to do a bit of cropping. So I'm going to go to dynamic crop, hold down control to maintain aspect ratio. And maybe just cropping a bit on the good stuff over here. No right or wrong answer, it's just how you want to do it. I'm going to click tick on that. And then maybe do a few more tweaks if you like, but that's basically the gist of that. So I hope that was useful. Thank you very much for watching, and clear skies.